Hi students, today we are going to see the topic about constitution of alloy. Myself, Sathish, Assistant Professor Mechanical Department at Akshya College of Engineering and Technology. In engineering materials and metallurgy, we can able to see the constitution of the metals, phases, each category of engineering application requires material for any or all these three groups of material. In engineering material, we can see metals and alloys as a group, ceramics and glasses as a group, polymers as a group. Based upon the application, we can able to split by structures, machines, devices. Here, metals and alloys having a group, ceramics and glasses having a group, polymers having a different groups. In this, metals and alloys we can see as including topics as steel, aluminum, copper, silver, gold, brass, bronze, aluminum superalloys, etc. Ceramics and glasses having a different structures of silica, soda, time, glass, concrete, cement, ferrite, etc. Polymers, for example, PET, PEFE, PVC, nylon, etc. Constitution of alloys. Constitution, establishment, foundation, creation, formation, structure. Alloy. An alloy is defined as a combination of two or more elements, of which one of the elements should be a metal in major proportion. The others could be metal or non-metal, for example, brass and steel. A solid solution may be defined as a solid that consists of two or more elements atomically dispersed in a single phase structure. A solid solution is composed of two parts, solute and solvent. In solute, a solute is a minor part of a solution or a material which is dissolved. Solvent constitute the major proportions of the solution. Both the solute and solvent can be solid, liquid or gaseous in state. The major element which is large in amount is called base metal or parent metal or solvent. The other element that is lesser in the amount is called alloying element or solute. It is the minor part such as salt or sugar which is less in amount. Bigger mixture is water, solvent, as an example. Classification of alloys: pure metal, solid solution, intermediate phase are the classification of alloys. Solid solution. A solid solution is a simplest type of alloy. A solid solution be defined as a homogeneous mixture in which the atom or molecule of one substance are dispersed at random in another substance. Solid solution further divided into substitutional solid solution and interstitial solid solution. Further, this substitutional solid solution split into two, disordered or random, ordered or regular type. Here, this picture represents substitutional solid solution. As an atom of the parent metal or solvent metal are replaced or substituted by atoms of the alloying metal, solute metal. In this case, the atom of the two metals in the alloy are of most same size. Ordered substitutional and interstitial component. In this picture, we can able to see atoms of solute and atoms of parent metals or solvent. Atoms of solute in a red color, atoms of parent metal or solvent in a green color. In substitutional solid solution, an element replaces host atoms in an orderly arrangement. But in interstitial solid solution, an element goes in holes in an orderly arrangement. Disordered or random arrangements are like this only. This picture shows solid solution. Solid solution are conductors but not so good as the pure metals on which they are based. Some examples of solid solutions are Cu-Zn alloy brass, NaCu alloy monal metal, AuAg alloy sterling silver, FeCr Ni alloy satin stainless steel, FeC alloy steel. Intestinal solid solution. The four elements hydrogen, carbon, nitrogen and boron have such small diameter that they can occupy the empty space intrinsic in the crystal lattice of many metals. Intestinal solid solutions usually have a limited composition range and are generally considered of secondary importance, but there are few instances worth of special attention. The intestinal solution of carbon in iron constitution the basis of the steel hardening. Very small amount of hydrogen introduced in steels during acid pickling, planting or welding operations causes a shaping decreases ductility known as hydrogen embrittlement. There are three possibilities solid solution based on the other amount of their elements. Unsaturated solid solution, saturated solid solution, supersaturated solid solution. In unsaturated solid solution, solvent is dissolving small amount of solute as well as at the given temperature and pressure. It is called unsaturated solid solution. In saturated solid solution, solvent is dissolving limiting amount of solute. It is called unsaturated solid solution. In supersaturated solid solution, if the solvent is dissolving more of solute that should under equilibrium, it is called supersaturated solid solution. Thank you for listening, students.